device we have discussed in the previous lecture about the transformer. Today AC generator means it is giving us AC voltage as an output. When we make the coil to move and which is kept in between the poles of a magnet, strong magnet, converting the mechanical energy into the electrical energy, and when we are getting the electrical energy we are getting it in the form of AC, means alternating current, which is a varying current. It means after every half cycle the direction is getting reversed. So you may call it as AC generator, or you may call it as AC dynamo or alternator. All these are the names with different names for the same device, which is simply converting the mechanical energy into the electrical energy. And in electrical energy we are getting the alternating current, and that should be clear. So we have to go in detail of the things, how it is constructed and its working theory, etc. So this is a diagram which is simply demonstrating you the various parts of the AC generator, which we are having the slip rings, we are having B1, B2 as the brushes. Load is always attached across which we take the output. Rectangular coil is there which is rotated in between the poles of a magnet. These are the poles of the magnet has been shown to you. So we have to make this coil which is already kept perpendicular to the magnetic field, and then we make this coil to rotate in the magnetic field, and because of that the induced EMF and hence induced current is. So it means you should be aware of the principle of AC generator, which is based on electromagnetic induction, and we have already discussed electromagnetic induction. You can always write it in detail that whenever a rectangular coil is made to rotate in the magnetic field, then because of the change in magnetic flux, induced EMF is produced and hence the induced current is produced. This is electromagnetic induction, and on that basis only we are able to get the alternating current as the output. So various parts, if I go with, these are the various parts of the AC generator. First is of course field magnet. Field magnet we have to generate by the U-shaped magnet where the two pole pieces are shown. Of course they cannot be separated. You know, we are having the U-shaped magnet, so both pole pieces for the AC generator where we want to get the less voltage, and otherwise we can have the electromagnet also if we want to have the strong magnet, depending upon what do you want the output. So for the small dynamos we are using the horseshoe magnet, or you can say the U-shaped magnet, and for the high generations we are using the strong electromagnet. But in diagram we are simply showing the two pole pieces here, which are N and S, and of course the field will go from N to S. Next is the armature coil, which is PQRS. This is the armature coil. Armature coil, it consists of insulated copper wire. It means laminated copper wire, and number of turns are there. N number of turns can be there, which are again bound on the soft iron core. And soft iron core again, and not as a single block but it as a splitted, so as to avoid the formation of eddy currents. So all the previous knowledge you should be having in mind, and you should be knowing which material which we are using for a particular thing, so that you are able to answer if asked in the conceptual problems. We are having slip rings R1 and R2. These are the slip rings. They are made up of brass, and of course they are fixed with the help of these brushes, carbon brushes. These are which are made up of graphite, B1 and B2. These brushes, carbon brushes, these are fixed with this load. And slip rings, they can get, means these brushes like clips, you can see like your banana clips you can see, or the crocodile clips I can say. So they can open and close depending upon when the armature coil is getting rotated. Then these brushes, they can open and close so as to give the movement to the slip rings. It means slip rings are fixed with the wire. So when the wire is rotating, slip rings are also changing its position. But B1 and B2 carbon brushes, these remain the fixed. And along this wire which is connected with this brushes, I am having the load resistance. Load resistance, that is simply a symbol. I can attach anything by which I want to get my electric current or your alternating current I am able to get, or of course a device which works on AC can be attached over here. Fine. So that should be clear. So this is all about the various parts of the AC generator which is working on electromagnetic induction. And of course electromagnetic induction means I'm producing the induced EMF or induced current by rotating the coil in between the field magnets. Or of course I can keep this coil stationary and I can rotate the magnets. Then also the same thing will happen as we have studied in the Faraday's experiments, that either I keep the one wire fixed and move the magnet, or I move the coil and keep the magnet fixed. The only thing is I want to produce the magnetic flux. So change in magnetic flux should be there, and whenever there is change in magnetic flux, then the induced EMF and hence the induced current is produced. So this was about the principle and construction. Now so working, you even if you don't draw these magnets and these things, you can simply draw this simple diagram showing the armature coil and showing the poles of the magnet, or simply you can draw the magnetic field lines. Magnetic field is from N to S. So this is the direction of the magnetic field, and I am making this coil PQRS. Of course, I am saying this coil has to be perpendicular to the magnetic field. We have to use the Fleming right hand rule, where we are having this, my forefinger of the right hand is representing the magnetic field. This is to represent the motion of the wire or the armature coil, I can say, and then the induced current will be given by my central finger. So this is by the right hand rule, you know. So what you have to do is, of course, these two should be perpendicular to each other. And then you have to rotate the coil, and when you are rotating the coil around its axis which is perpendicular to the magnetic field, then I can get the direction of the current by using the right hand rule. So for every arm you can find the direction of the current by using simply the right hand rule. So induced EMF which is set up is found by the right hand rule, and if you do for this, so I am getting the current in this direction, it means in the clockwise direction. It means when I make it rotate, P going down, RS is coming up. Then further if I after half rotation again PQ will come up, RS will go down. So you can always keep finding the direction of the current. So one way we are taking the current as positive and reverse current is taken as negative, and that is why we are saying that the current is alternating. Or we are getting the sinusoidal wave, I can say, and sine wave. So this thing can be understood when we are having this coil is kept in between this field, magnetic field. Whatever way you can draw, that is okay. Your choice where you want to draw north pole or south pole, the direction can be taken accordingly. The only thing you need to understand is that when this time and with angle, we are just simply looking for the direction, induced EMF or induced current. The same thing I will be getting, because EMF and current, they are directly proportional to each other. So when first case, when theta is 0, then we are saying that no EMF. When you are turning it, when it is getting rotated, when armature coil is rotating through 90 degree, means it is becoming parallel to the magnetic field, then we are getting the induced EMF because of the change in flux. Again, when you turn it further, then it is becoming 0. Then again you turn it to 70 degree, then it is becoming maximum. So at 360 again it is becoming 0. So this is one complete cycle. It means I am moving the coil from one position to this, then to this, then further, and then so on. I have to make complete circle. So when I'm completing the circle, the current is getting changed, or I can say induced EMF I'm getting is in this form, that is the sinusoidal form. It means it is changing after every half cycle, and this is termed as your alternating current and induced EMF or I, whatever graph you go with. So this is with the change in angle or with the change in time. You can say when time is t by 4, t by 2, 3 t by 4 or capital T. Like when we do with one circular motion. So one circle when you are completing, starting from a particular point to come back to that particular point. So then you have to study how the EMF is getting produced. This we can write in the terms of mathematics. When we are writing it mathematically, then what it is, you all know flux, it is given by NBA cos theta. This is formula we have already derived for the flux, that is B dot A, and for n number of turns I have to multiply this with capital N. So B dot A can be written as BA cos theta. So theta is of course the angle which is there between this coil and the magnetic field, of course perpendicular to the coil, of course. So when initially when at t0 when you are putting, so that graph can be understood again in this mathematical terms also. So what it is, that when theta is 0, then cos 0 is yours, this theta at time t equals to 0. So what you will be getting, theta will become equals to 0. And but what we have to find, we have to find the EMF. EMF is minus of d phi by dt. So phi is this NBA cos omega t or cos theta, whatever you write. When we talk in terms of the circle, then theta can be replaced by omega t. Now if you differentiate, you can obviously find d phi by dt. NBA is constant and cos omega t will be equals to minus of sin omega t into omega. Now this minus and this minus will get converted into plus sign. So I am getting the EMF is NBA omega sin omega t. Or I can call this constant value NBA omega, that is the maximum value I will be getting if sin omega t is equals to 1. The maximum value of this EMF will be equals to E naught. And so E naught I can write it as NBA omega. And if I want to write instantaneous current, that is obviously EMF upon the resistance of that coil, so can be written as E naught sin omega t upon capital R. So I am getting the expression in terms of sine, and now if you put the value theta equals to 0, then sine 0 will give you the EMF equals to 0. When it is 90 degree, then sine 90, you have to take the value, that becomes equals to 1. So I am getting E equals to E naught. When I am getting it pi, means t by 2 time 180 degree, then sine 180 is again 0. So you are getting it 0. So this is with the help of mathematics. If you want to put the values and see the graph for the variation for EMF, the same graph I am getting, which I simply explained you while explaining the working. And of course current, it is equals to E naught sin omega t upon R. So the value of the current magnitude will be less. If you want to draw for current, you can always draw it for current also. Then of course the magnitude will be little less, but the shape of the graph will be same. Shape of the graph will be same, but the magnitude will be little less. So you can get the graph like this. So means you should be able to, of course, do the graph plotting for the current, but the direction will be same. Means whenever the EMF is 0, current will be 0. When EMF is E naught, current will be equals to I naught, I can say, and I naught will be equals to E naught divided by capital R. So I can write I equals to I naught sine omega t. So direction means if it is sine graph, this is also I am going to get a sine graph with you, which is sinusoidal graph, I say. Now this is when I am making one coil to rotate in the north south pole, then I am getting one phase of current. But most of the times you come across this word that at our places we are having three phases, or mostly in factories we prefer to have three phases. So there we use three phase AC generator, where I am having three coils which are kept at an angle of difference of 120 degree each, like this way. So I am able to get three phases at the difference of these angles of 60 and 120, like this. All sine graphs will be there, but which phase you want to take at one particular time you can always decide, and you can turn the switch on for that. But it is obviously we are making it for the purpose so that at all the times we are able to get electric current at our places. Of course we are using AC at our places, you all are aware of this thing. And three phase generators, only we are having three coils, rectangular coils. Construction will be similar, but we are having three armature coils with us, which are inclined at the angle of 120. That is a polyphase generator, we say. For commercial purpose or otherwise, when we are using, how we are able to get the electric current generated, there are three type of generators with us. Like we are having hydroelectric generators, where we are like in dams, we are using the storing the water at the higher heights, and then we allow them to fall. So potential energy is getting converted into kinetic energy, and that kinetic energy is made to fall on the turbines. Turbines means again the armature coils, which are connected with the slip rings and brushes arrangement, and then I am able to get the electric current. So mechanical kinetic energy, you can say, is converted into the electrical energy. In thermal generators, we are burning the coal, or any fuel can be burnt to boil the water. Steam is produced, and that steam is used to move the turbines. In nuclear generators, again in place of coal, we are using the nuclei, or we are using the nuclear energy to produce the steam. Now when we are having the, nowadays when generators are there, we are able to generate the electric power as high as 500 megawatt. It means one can light up 5 million 1000 watt bulbs. That much we are able to generate at one time. And most of the times we are having the coil stationary, and it is electromagnet which is rotated, because it is not feasible to rotate the coils all the time. So that method also can be followed. And you should be knowing that the frequency in India for the electric current is 50 Hz. And on that you will be doing one experiment. To certain countries we are having even 60 Hz also. Of course we are using AC in our places. Why not DC? Because there are certain advantages in using the AC, as we have said, that we can easily step up or step down by using the transformer. We have already discussed how we are able to step up or step down. Of course the generation is economical, and we can transmit it to different places without any significant power loss by using the transformer. And at times when we want to work with DC, I can convert AC into DC easily by using the rectifier circuit. Rectifier circuits are quite easy, feasible to make, so I can convert the AC into DC comfortably. So that is why AC is always preferred over DC, though there are some advantages also, that of course it is dangerous to work with AC, so you have to be extra careful while working with AC, because the peak value of AC is very high, which is root 2 times IRMS. It means root 2 times 220 volt. So it becomes very dangerous to work with AC, so you have to be extra careful. In phenomenon like electroplating, electrolysis, we cannot use AC, we have to work with DC. So, but we can convert AC into DC by using rectifier circuit. So this problem is sorted out. Of course, AC is transmitted more from the surface of conductor. So we are not using a single thick wire. We said that resistance increase, we can increase by using the thick wire, but thick wires we cannot use. So we are using fine thin wires, which are of course insulated wires, and then they are clubbed together for the transmission of AC. So this is one thing which you should be keeping in your mind, which is the disadvantage, but still it is more feasible to transmit AC than working out with DC. So advantages and disadvantages should be clear with all of you. One simple question with you. An AC generator is consist of 50 turns and area is 2.5 meters square. This is the question given to you, that the coil which is there kept in between the magnets, that is number of turns are given 50. It means capital N is given 50, but you keep writing along with. Area is given 2.5 meters square. Rotating at an angular speed omega is given 60 radian per second, and a uniform magnetic field is given to you 0.30 Tesla between two fixed pole pieces. It means we are rotating the coil, pole pieces are fixed. The resistance of the circuit including that of the coil is 500 ohm. So resistance is also given to you 500 ohm. What is the maximum current drawn from the generator? You have to find the maximum current. You have to find the flux through the coil when current is 0, and when current is maximum, then also you have to find the value of the flux. It means flux is also to be calculated. And the third part is, would the generator work if the coil were stationary and instead the pole pieces rotated together with the same as above? It means if omega is kept same, then of course it will not make any difference, that we have discussed in theory also. So we have to simply find the maximum current and flux for the different values of the current. This is the question, and the given things already has been noted by you. So you have to look for the solution. Number of turns are given 50, area is given 2.5 meter square, omega is given 60 radian per second, B is given 0.3 Tesla, and R is 500. So maximum current I naught will be equals to epsilon naught upon R, while epsilon naught is the formula is NBA omega. So N, B, A and omega all are given, and in proper units they are given. So no need to convert anything in some other unit. So simply you have to put the values and work out the things. That is coming out to be 4.5 ampere. Now if you want to write the value of current I, which is equals to I naught sin omega t, which is equals to E naught upon R sin omega t, it means NBA omega upon R sin omega t. And flux is what? That is NBA cos omega t. These are the formulas known to me. Now flux will be maximum if cos omega t is 1. It means cos omega t is having the maximum value, then only the flux will be maximum. It means cos theta is 1 means theta should be equals to 0, or omega t should be equals to 0. So if I put this value 0 here, I am getting the value of flux 5, which is coming out to be, by putting the values, it is coming out to be 37.5 Weber. And current is maximum when sin omega t is 1. It means omega t is equals to 9. So at that time, of course, flux has to be 0 because cos 90 will be equals to 0. So you should be able to solve whatever is asked in the question and give the solution accordingly. And generator, of course, will work because we have to simply produce the magnetic change in the flux. Flux change should be there, that I can either by either moving the coil, or I can move the rotate the magnetic field, then also the same thing will happen. So of course generator will work, as nowadays we are preferring rather to move the magnet at that speed because it is more feasible. So of course more questions can be done, and you keep thinking for today. Thank you everyone.